Good morning. Before we get started, let me just ask if any of you have any questions that you would like to ask. If you have some issues on your computer that we might need to solve, as we did last week. Just feel free to ask. Okay. And now I'm sharing my screen apparently, right? Hopefully. Okay, so I had to switch to Linux now, funny. I upgraded my operating system last week, or a couple of days ago. And since then, Windows doesn't start on the VirtualBox doesn't start on my machine. So I have to fix it. I couldn't fix it. I just realized it today. So I'm switching to Linux. Nothing should be really different because we are using Visual Studio Code. And anything that we write in Python, basically almost anything that we write in Python is the same regardless of the operating system. So it will be fine. Okay, here I'm on the command line. I started basically, actually I don't really need the command line because I can use Visual Studio Code for everything now, I think. Okay, so here are the plans that I tried to put together. First thing, I think I should go over a little bit of the solutions, or actually a couple of issues that I encountered people doing it. One of the things is commenting. A few people added way too much comments to their code. There is a huge debate all the time among programmers or people writing programs or whatever I should call, how much commenting there should be. Some people say, oh, some people complain that when they see a piece of code and there are no comments and no explanations. And on the other hand, extensive commenting can be also problematic. So for example, if you write something like this, exit, and then put a comment and the program, that's just really unnecessary. I mean, if someone doesn't understand that exit will end the program, then it's probably better that that person won't touch the code at all, because that should be basic, right? Now, obviously you're learning, so everything that for a programmer should be basic might be new for you. So that's not trying to judge anything on that. It's just the pointing out that these things should not be commented, okay? Because that's just adding extra noise to the program. And there is a huge problem actually with comments. For example, if we have, let me have you another example here. Let's say you have this code. Let whatever counter, okay? Counter equals to 0, and then someplace you put in counter plus equal 1, okay? And you say add 1 to the counter because, well, whatever. And then later on you go and, well, for whatever reason you change this, because that's how the program should work. And there will be quite often times when you will forget updating this one because you are in a hurry. So you are just updating this one. Maybe you're exploring something and changing one value and saying to yourself, okay, I don't know if I'm going to change it permanently. I'm just experimenting with it now. And then so I'm not updating the comment because that's just a waste of time while I'm experimenting. And then you leave the changes as they are, now having this 2 and here having 1, and then this is the comment. And now the comment contradicts the code, which is just think about it. You come read some code, and then what's going on? You try to understand. Is it incorrectly adding 2 because it says it should be 1, or the comment is out of date, or what? Actually, if we are using version control, as we are using now Git, then it is possible to go back in history and see when was this line changed, and then it will be you can use the git log and see when this changed. Actually, I can show you this one now. Let's see this one. Okay, so I have this code, and I'm going to commit the changes. Okay, which button? Yes, yeah. So I can do this here on the command line, git status, right, and git add plans, okay, and git commit add example. Fine. Okay, and then I go and make this change, and I'm going to change this, and then now and make some other change. Okay, so I add some other code, and example when comments go bad. Okay, so I made these changes: git add, git commit, add comment, add sentence. Okay, and then we can go on, and now I can type the next thing, git blame. Okay, it's not really nice that they are called it git blame. They could have called it git praise, but this is the name that some people rename the command. So I say git blame and the name of the file, and it will show me the file as it is. On the right-hand side, you can see the content of the file, and on the left-hand side, you can see who changed that line the last time. Obviously, on this code base, it's on this file, it's just me, but you can see also when was the change made for each line separately, and this is the ID of the change. So if I go to this line now, and I copy this ID basically, then I can say git show and paste here the ID, and I can see the exact change that was made. And if I made good explanation in the commit message here, add sentence wasn't that good, but if you make a good explanation, then it's going to be easier to understand why was this change made. You will also see that when this change was made, this to 2, then this other thing happened as well. So you understand you might understand more what is the context of the change. And from there, you can figure out what's going on. That's assuming you have version control like Git. You use it frequently and not just once every 3 weeks you make everything committed, okay? But you do it frequently. And when you're reading the code, you actually have access to this Git history, because if this is a code that you send over just the final version of your code, just the last version that you have, and you send it to someone, that person won't have access to the history of your code. So this is a good idea. Now, if I push this out, the whole thing, okay, I push this out to the Git repository here. We can also see, I can also reload this. I can also come here, click on the plans file. In this case, I know that I would like to know what. And here too, you have the button that does this blame thing. Okay, and here too, I can come and go and see, oh, this is the change, and then I can click on this somewhere where blame, which one? Add sentence. Okay, here is the explanation. I can click on this one, and then I can see in the browser with more colors. I don't know. They actually change the same thing that I saw on my computer. So you can do this as well on on the website as well. Okay. Yeah, well, sorry, I go back to that point where so here it somewhere, I don't know if I can see here. Let's go back to this page. So here this is when I clicked blame, and it doesn't show the actually ID, but if you squint and you see at the bottom, when I put the mouse above it, then you can see that long ID just at the bottom of the screen. That's the long version of the ID. Here I think actually you can add sentence. I think when I clicked on this one, here at the top, you can actually see the long version of the ID. Okay, so the same ID that we had here, this DD32, okay, this is actually the beginning of that, the DD32, E46F, E46F, whatever. So this is the long one is the actual ID, and the short one is just a short version of it. But because you don't have many changes and many IDs in this, even this short one is unique, and that's why it's used in many places. Anyway, the whole thing started from the point that I wanted to tell you that not to do a lot of comments, not to add unnecessary comments. That's the right word. Okay. On the other hand, if you have some code like this, and this was taken from one of the solutions of one of the students, which was fun because to the game they also added this score thing, and here they have this N, which is unclear, absolutely unclear what it is, and the T. So I would recommend, and I actually wrote that students to use more meaningful names. So these one-letter names are really difficult to understand, and in this context, really, I'm not sure what they mean. So just by having longer and more meaningful names, the code will be clearer, and reading the code will be easier. That's one thing. But this line of code probably needs some explanation. And actually, that person had the explanation somewhere else, where the person described what is the scoring system. So I wouldn't repeat it here. And that was like the user-facing documentation. So the player will be able to understand that it will be scored based on how long does it take to play the game, and how many tries were, and so on. So here I wouldn't repeat that same explanation. I would just refer to, the explanation is in the user documentation at that point, and that's it. So because if you duplicate something, then again you have the chances that in one place you change it, you update it, and the other place you don't. So this is the reason I mentioned several times not to repeat code, and what we call dry in programming. This is the same idea why it's better to avoid documentation if it's not really necessary, because the documentation is basically repeating partially the code. So the usual case that you want to add documentation, or these comments, not documentation, comments, is when you want to explain why you do something. Okay, so here I put it here. So usually the comments should go and explaining why you do why you write some code, not just what you do. Okay, so there will be cases when you try something, solve a problem, and you find out that it's either too slow or doesn't work properly or whatever, but it still seemed obvious, and so you change it to some other solution, and then you might want to explain the first one actually as well, saying, okay, I tried that and that doesn't work because of ABC, whatever. And then I'm doing this is the way I'm doing, this is the reason I'm doing this one, because that way wouldn't work, even though that seems more obvious. So that kind of explanation could work. Okay, so that's the first thing. Now let me move this, whatever we had, to the README file. And at the end of the README file. So it's not plan anymore. This is what we did. And I can also add here what we talked about. It's a good idea that I'm writing here now, because it gives you opportunity to ask questions in the middle. Right. One more thing, if we are already here, and we talked a little bit about version control. So far, I used only the command line to git add and git commit and git push. Maybe it's time to show you that here inside Visual Studio Code, and probably in other environments, if you're using other editor or something, many of them have some integration with Git. So Visual Studio Code has this integration. And this thing that you can see here is this number 2 is talking about that thing. So I clicked here, and what it says basically that there are 2 files that changed. And then I can go, let me see it here as well, git status. So it's basically sort of saying what git status says, okay? And I can commit here. Now I'm quite sure that, okay, I clicked on it, and now it shows me the difference. Nice. Okay, so it's what the git diff does. So most of the operation that I showed you on the command line can be done here as well. I personally rarely use this, but people like it, so I guess I show it. So now I click on the commit, and there are no staged changes. You remember when we were on the command line, we first said git add, so staging the files, and then we made the commit. Here, it doesn't, I mean, maybe you can right-click on the file and stage it or something, but I don't know. So there are no stage changes to commit. Would you like to stage all your changes and commit them directly? Well, yes. Okay, right now, yes. But you might want to have more fine-tuned changes. You'll figure it out, I guess. So now it opened an editor where it allows me to type in my commit message. The one that here I usually put it -m and some text. Here it gives me the editor, and I can add my text. And so move some items from plans to README. Okay. I can remove these things that are commented here, or I can keep them, doesn't matter. This won't be included. It also explains with all the lines that start with a hash mark will be ignored, so it doesn't matter. Now I close it, and it committed, okay? It made the changes. So if I run git status, you can see that now there is one commit, the changes, they are not modified anymore. But they are still local. They are not pushed out. And so it immediately also offers to sync the changes. Now you can decide whether you want to continue working and making more changes and committing more changes before you push it out to GitHub. The sync is basically doing, I think this one is doing both ways. So it will push out changes, and if there are changes in the remote repository, then it will pull them down. In our case, that doesn't happen now, so I can just click it, and this collection will pull and push commit. Okay, and I'll let it show it again for now. So next time I try to show this, it will still do it. No, I don't want it to fetch. Okay, so git fetch would pull down basically all the changes from GitHub if there are changes. This can be useful. That's what it offers me. It can be useful maybe if you are working with multiple people and they all pushing out changes to the Git repository, and you want them to be local to your computer to make it easier to integrate things later on. I don't want it. Okay, I can tell it ask me later. Okay, so again I can show you, show other people. So that's it. Now I can click on this one again and it will disappear. So as you can see, I can do most of the stuff that you can do on the command line with Git also inside here. I'm just less familiar with it personally. Okay. Next thing, again, from the solution. So many people had code where this is basically how they think about it. And this is how, at the end, normal people think about it. This is how we discuss the game. So the game was like this. The computer, okay, something is, I hope that the sound is still working because my microphone is disconnecting once in a while. So the story with the game was that the computer thinks about a number, then the user guesses, and then if it's incorrect, then guesses again, and then, okay. So we had a while loop basically there, letting the user ask, guess, and the computer answering. And then we said, if the user presses X, wait a second, someone's writing me, and they, okay, thank you. So if the user presses whatever N, then we start the game again. And because you started the game by calling, let's say, the main method, main function, or game start mention, or whatever, here at this point, you're calling that function again. And then if the user goes on and asks it again, then it will be called again. And so, which sounds logical for regular humans, but programmers understand that what it creates is a recursion of calls. So the one call calls something which calls basically itself. Okay, maybe there are functions in the middle, but basically at the end there is a chain of command that, let's say, main starts, and then it calls some function, and that function calls main, and that function calls that the function again. But basically, we can think about it that the main calls itself, and then calls itself and itself. And it goes into some depths. Now, this is called recursion. And we'll discuss the recursion because it's a technique that's used often in programming. It's a very good technique, but if made by mistake, then it's not good. Okay. The point is that you don't want very deep recursions because they are wasteful for the computer. The computer has to remember all these calls, all the stack of the calls, and so it's better to, in many cases, it's better not to use this recursion. So there are two main examples that are used for recursion. One is factorial. So factorial is what you but in math you usually see it as n exclamation mark, and then it can be explained in two different ways. One way is saying n exclamation mark is n times n minus 1 times n minus 2 and so on till 1. Okay, so the multiplication of all the numbers between 1 and n, basically, that's the sentence. Now, as you could see, I couldn't write it the whole thing because I don't know what n is. So that's one way to explain what is n. The other way is saying that, and this is basically this is how we say it. Fn equal, this is the more mathematical way to write it with the f. So the recursive definition would be like this. F1 is 1, or I can even say, you might even say F0, but that doesn't really matter. F1 is 1, and then Fn equals to n times whatever Fn minus 1 is. Okay, this is the recursive definition. So basically we say if we know how to compute 9 factorial, then the 10 factorial is just 10 times the 9 factorial, which is logical, right? The nice thing about this is that I could explicitly write the whole thing down here. Here I couldn't write it. Here I had to rely on these dots and so on. So when I need to implement it, this is the whole implementation. So let's try to implement this now. Now let's create a program which will get the value. Let's say it has a main program, and that's calls, and we call print on the factorial of n. Okay, and here we say n equals to 3. We call this main function, but we also, of course, have to implement the factorial. Now, where was this? In the plans, I had this. So this is basically, I'm copying now. What is the definition? And except of f, I use the word factorial because, again, just what I said earlier, it's better to have a longer and clearer, clearer name. Okay, and well, I could do this as well. So I define the factorial function as accepting an n number, and then saying if n equal to 1, then return 1. Otherwise, return n times the factorial of n minus 1. Okay, so let's try to run this program. I have to save it. Okay, and for this I need to create a folder. So let me try to use everything here. New folder. So I don't rely on the command line now. Where can I create new folder? New folder here. Day 04. Okay, by the way, I put this 0 so it will be nicely ordered even when we get to 10. Okay, this one, I don't need it. Now I can save this. So it's opened, and in the day 4 I put in, and the name I wanted to use is factorial. Okay, so I can run now Python. Actually, I need to write Python 3, day 04, day 04 factorial. And I probably need to enlarge this. Okay, so I ran this and I got 6. Okay, what if let's actually get this from the command line. So if import sys.argv, if len of sys.argv is different from, okay, so did we discuss sys.argv? No, we don't have it here. You see, this is why I need to have information in the command. Yeah, okay, we'll discuss it. Let me just write it now for now. Exit usage sys.argv 0 number. Fine, and then this is sys.argv 1. And let's change a little bit this one as well and say it's an F string and it will include the n and the factorial of n. Let me int. Okay, let me see if it works, and then I can explain to you what I'm doing. Okay, 3. Nice. 10. Okay, so when you are running a program, you can pass. So far, we were running programs this way: Python and the name of the file, right? But we can also provide type in, okay? We can randomly type in stuff here, okay? Whatever, okay? And many programs are accepting input from the user that way. It's called the command line, okay? So far, we were only using the input function in order to accept parameters from the user. And we weren't looking at the command line arguments. So how can the program know what was written here on the command line? So let's say I put it the number 3. How can the program know what is written here? Python provides us a library called sys that we can import, so add to our program. We don't have to install anything because it comes with Python. And then this sys thing has all kinds of attributes. It's like the random library, right? The similar idea. We imported it, and then we can use methods of part of it. So there is this sys.argv, which contains as a list, okay, just like we had the counters with 10 numbers in it. So this sys.argv is also a list that has all the parts that are on the command line. Okay, all the information on the command line. So before I continue, let's just print this out. Okay, I print the content of sys.argv. Okay, so you can understand it. So now you can see that it contains, this is the list, okay, in square brackets, and there are 2 values in the list. Okay, the first value is the name of the program itself. Okay, so I ran Python 3 and then the name of the program and the number 3. And the second value is that number 3. So whatever I provided to the program. So whatever comes after the word Python 3, or probably in your case Python, that all those parts are going to be in this sys.argv. If I provide here hello and world, then how many entries am I going to get? Think about it, and if you can tell me, please, while I'm drinking tea. Okay, no one is daring to open the mic saying. So we have this, the first one is the name of the program, then this number 3, that's 2 already, the word hello, and the word world. So there are going to 4 elements. I can print it out. Actually, let me also print out the length of it. So print len of sys.argv, so we won't have to count, okay? So here you can see that there are 4 elements in it, and you can see these are the 4. Now I could do, if I wanted to provide hello world as 1, I can put quotes around it. And then there are going to be 3 elements: the name of the program, the number 3, and the string hello space world. I said the number 3, but you can see there are single quotes around it, because in reality, Python doesn't know that this is really a number, okay? It considers everything as a string, just like when we ask the user with the input function, right? We ask the user, please type in some number. The user was right, and correctly and typing in a number. But Python still didn't know that it's really a number. We still had to use the int function or the float function to convert that number into an integer that Python considers an integer, or a float to what Python considers a floating point number. So here too, it will have the same issue that whatever the user provides on the command line, even though it might look like a number, and we might talk about it as a number, in reality, Python thinks about everything as a string. So what we have here now, okay, instead of, so now you can understand that the user can provide anything here. And so you, as the programmer, can say to the user, okay, I'm expecting you to provide the number on the command line that we're going to use for the Fibonacci series. So what I'm expecting is that I'm going to get exactly 2 values on the command line. The name of the program is always there, okay? So that's always there. So if I'm expecting actually 1 number there, 1 value there, then I'm expecting 2 values. So what I'm checking here is I'm checking whether the number of arguments on the command line is different from 2, because I'm expecting 2. But if it's different from 2, then either the user didn't provide that number, or the user gave me all kind of other values, which is indicates that probably the user is confused, okay, of what we are expecting of her or him or whatever.
Could I ask a quick question?
Yes.
Just to clarify. So if I understand correctly, the arg is number of arguments. That's what we get.
The argv is the list of all the arguments. So that's why we use len.
Is the list of arguments. Okay.
Yes.
Okay, thank you.
Okay. So this sys.argv contains the list of all the arguments. So whatever we printed here, okay, the first print. And then we use the len function to get the length of it, which is the number of elements in it. Okay.
Got it, thank you.
Okay, you're welcome. And I'm really happy to, I would like to make sure that you understand, everyone, that it's a good thing to ask questions, okay? That's how I get feedback, okay? So I wrote you in the email that basically, based on feedback, you are learning. So now I get feedback that something is unclear, and then I can explain it. So, so we are checking here if the number of elements is different from 2, right? Because 2 is good for us, but if it's not 2, then we would like to report to the user. So what we do is called the exit function. The exit function will immediately stop the running of the program. We saw it, people used it already. I even had this in the comment, okay? So the exit function, but the fancy part of the exit function is that you can put here a text, some string, and then Python will print it, okay? That message. So now let's say what happens if I run this program and with the same parameters. It tells me that the usage is, and I forgot the F, and no one is telling me. Okay, so let's do it now again. Okay, so it prints out usage, name of the program, and then the word number in capitals. Okay, so this is what I wrote here. I said print out the word usage, then sys.argv in the zeros place. So sys.argv index 0 is the name of the program. As you saw in the previous examples, in this list, the very first thing, which is index 0, is the name of the program. Okay, I know it's confusing a little, then the indexing starts from 0, but just think about the elevator, right? Floor 0 is where the entrance floor. Okay, so this is going to be the name of the program. So what I am personally, Gabor, trying to do here is printing out some information to the user, and hopefully when the user sees this message, usage, name of the program, and number, hopefully the user will understand that she has to provide me a number there. Now I could put here more explanations. I could put number for, I don't know, what is this, factorial, whatever, okay? I could put there any text here, And then when I run this, I would get that all this explanation. Okay, I could put multiple lines there, whatever. Okay, it doesn't matter. I usually put just a short version of it there. Okay, so what if the user doesn't provide any value, I get still the same error. But if the user provides the correct number, then I don't get the error, because now I have exactly two values on the command line, the name of the program and this number 3. And then this exit is not called, and then we go on. Okay. Now I enable this one as well. So we take the sys.argv in the first place, or once, whatever, index 1. Okay, the right word here, index 1, which is the second place, right? So this, if I scroll up again, this was the zeros place, index 0. Let me rephrase. The first place, which is index 0, and this is the second place, index 1. So index 1, okay, we are using index 1 here. And so this is going to, or expected to be, I mean, the programmer expects that the user types in the number there. And here, now I run this number. So now I run the program again with number 3. So n becomes 3. Then we call the factorial function with number 3. It returns the result. We'll look at the factorial again later. Okay. And then I print out the result. If I provide incorrectly text here, then the whole thing blows up. Okay. And it will tell me that the invalid literal for int. And I can even go back and see that's line 9 here. Okay. So line 9 here. Okay. It's not really nice that I, the programmer, didn't verify that the input was indeed, that the value that the user provided was indeed an integer. So this whole thing blew up. But on the other hand, I did tell the user to type in a number, right? So, well, let's even improve that. Some people use this one, sys.argv 1. And then I think I can type is numeric. And I can say if not is numeric, then okay, I have this one as well. Let's see if it works. Right. Okay. So now I duplicated it, and I told you not to do it. So I'll have to, maybe we have to figure out how to do it, how to not to duplicate this error message. But we fixed the problem. So when the user provides something which is not a number, let's see what happens if this one still the same message, so it doesn't blow up. Good. Now I can provide 2. So the factorial of 2 is 2. Of the factorial of 3 of 6. Of 4 is 24, and of 10 is a lot bigger. So far, good. Okay, can we really improve this to eliminate this duplication? Well, we can say if is different from 2. Let me put this in comment. Okay, so we'll have this here, and then I just duplicate this code. Okay, so this will remain here in comment in case it's easier to understand. But what I say is now that I can do the following. So if is different from 2, or not numeric, then do this. Okay, let's see if now the program still complains in the right places. So if I type in 2, complains. If I type in values, okay. If I type in 3 and something, if I type and nothing, it still works. Okay, so I tried all the combinations here, I think. This basically says the same thing what we did for earlier, but now we only have one place to when we print out when we call the exit function with this message. You might, I mean, it's okay. You might simplify it, because there are now two negatives here, sort of. So we can maybe change it, improve it a little bit better, but it's fine. Okay. It could have been in a different way. Let's try another one. Okay, so this was, let's copy paste again this one and see if we have another solution for this condition. No, actually, no, we won't. Okay, good. So we understand now, hopefully, what is this sys.argv, okay? That it can provide me on the command line something. Before I continue with that, I would like to show you why it's actually very useful to use this command. So we had this solution now where we can, so that I could run it and just change the parameters on the command line, and I could even go back in history and find executions of the program that way. What if instead of working with the sys.argv, I'm going to change this now? Okay, this whole thing, I'm going to change to this. What we already used, that I asked the user with input. Okay, so let's run this now. It asks me, and now I can type in a number. And I forgot to call int on this one. Okay, run it again. It worked. Run it again. Now, okay, so what you can't see, because I'm typing it and you can't see my hand, but you can understand that it takes me a lot more to again type in the input number. And this time, it's only a single number that I have to type in after I started to run the program. What if the input, let's say in your case, you're writing a program that accepts two file names of two Excel files that you need to read, and then a third file name where you have to write out whatever computation you did based on these two files. So let's say you have a program that expects three file names, and the first two will be the input files. You are going to read them, do some computation, and the result you write out in the third file. Now, if you are using the method, this variation of asking the user with the function input, that means that for every time the user runs, she will have to type in the name of the file. And if she makes a typo, then the whole thing is ruined, right? Then you have to start it again, or ask the user again, or whatever, and then she has to correct it. On the other hand, if you're using this sys.argv way of accepting values, so the user has to type in here name of the file .xls and some other name of the file xls, and let's say this is the blue results, okay, blue, and the green, whatever, and this is the result xls. Okay, so now if I make and then run this program, now it will ask me, okay, whatever, sorry, let's just leave this comment this out now, so it won't ask me again. So I run this, and I run it again. Okay, it gives me error messages, but it's very easy for me to run again the program, slightly correct, let's say, the input, okay, just by editing this line, and run it again. And I don't have to type in again and again and again the name of the file. Now, this is extremely helpful, especially when you're I mean, both when you're developing the code and you're running the same code with the same data again and again, and then you're still okay. So some people will solve this by putting the name of the file into the program. Okay, saying file equal to blue XLS, whatever. That's sort of problematic because then it means that the program can only use this file name. And out in the wild, you probably have all kinds of file names for this input. Worse than this, actually, many people put here the name of the file path of users. Let's say some of the students are called foobar. I don't know if there are any. Research, whatever. Okay, so you have the file name in the name of the file here. But that means that only foobar can run this program because only foobar has this folder on their computer. So this is not a good idea. I mean, it's a solution, but it's not a good solution really. So it's not, yeah.
Sorry, just a question. So you kind of answered my first question. I was wondering from the beginning why you didn't have the inputs when we started this script.
Yeah.
So now I see the benefits of using the sys.argv, but when would it be more beneficial to use the actual input function?
I think quite rarely.
Okay. Okay.
I think quite rarely. Sometimes I mean, it was beneficial for the game, right? So if you have, it's an interactive thing where the computer does something and asks you questions and does something else and asks you questions. In that case, it's input, right? Because the program, while it's running, it needs to ask questions. But if all the input is expected up front, then the sys.argv is probably better.
Okay, thanks.
Okay. So in the case of the game, the input was necessary. You couldn't handle it with the sys.argv because you keep responding to whatever happened in the game, right? In the number guessing game. Yeah, in this case, this is much better. Now there are other ways. I have some various slides where so you could also create what we call a GUI, a graphical user interface, which will be much more familiar for anyone using Windows, like a window with buttons and all kind of stuff. You can create that, and it will probably be nicer for all the users if you provided that. We didn't start with that because that's just extra things to learn, and it's extra work for you. Okay, so I'll show that example later, but I would like it's too much now. I'm still talking about factorial. Okay, but now I already went to talk about input methods because I started to use that. So I'll show that GUI thing later on. The only thing I said about that is that it can be much nicer, much more user-friendly. It still suffers from this. It might still suffer from the same issue of the input that you have to type in again and again, and you can't reuse the history of the commands you executed. But it might be. But then also you have to write more code. Okay, any more questions, by the way, here? Okay, so I have to restore here the parts that I wanted to use. So this one, I think, were part, and I just put here a comment. It is to hard code passes and file names. Okay. And then we have this. So let's see if this works again. It works still or whatever. factorial. If I run this, I get, if I give 3 and 4, then it still complains. If I give 3, works. Okay. So this is what we call a recursive implementation of the factorial function. So let's try it. I don't know if it will work. Let's try what is factorial 1000. It blows up. Actually, if I try 900, let's say 900, then it's just a big number. Okay, it's a very, very big number. But if I try it with 1000, it blows up. Now it doesn't blow up because it runs out of memory or whatever. It gives me the recursion, maximum recursion depth exceeded. And it says repeated 995 times. Okay, I knew that it's just under 1000. So because of this recursive call is rather expensive, because Python, or the computer in general, has to remember all the calls. And all the calls, all the history of the calls, all the depths, that's to remember. So it's rather expensive. So and in general, you don't usually write any recursive function that it's very, very deep. So it calls itself. Okay. In our case, we called factorial 1000 times. So factorial code itself. It's going to be very boring if I'm telling all that 1000 times. Okay. In order to protect us from, okay, so mostly you don't need any of this, any such recursive. So if this happens, that the code runs so deep, then it's probably because you forgot to do this. This is a critical part of any recursive function. This is what we call the stop condition. If without this, the calling of the factorial would never end. So let's say I comment this out and I run this now with only number 2. What do I get? I get the exact same error as I got with the 1000. Why? Because what happens is that we call factorial with number 2, then it will call it with itself with number 1, then it will call itself with 0, then it will call itself with -1, then with -2, and so on. Okay, we made a mistake here by commenting this out. We made a mistake that we didn't have put in a stop condition that will tell. You remember the definition here? So this definition wouldn't make any sense without this part, without the first part. That wouldn't make sense. We have to tell it, okay, for some small number, we know the answer. For any bigger numbers, we just deduct, we just try to compute it from the earlier results. And I see it's 10 o'clock, so I have to really make a break. But before we go for the break, let me tell you a story that I studied mathematics in high school and at university at the beginning. So I'm sort of considered a mathematician. So, and you're a biologist, so it's probably most of you. So it's going to be interesting. So the story goes is that what's the difference between actually I think it's physics, but it doesn't matter. How do you boil a water which is 40 degrees right now? How do you boil it to 100 degrees? Well, you put on the stove and you turn on the stove and it boils to 100 degrees. So if I give you a pot of water with 60 degrees water in it, how would you boil it to 100 degrees? So the biologist and the physicist would probably put on the stove and boil it up, right? The mathematician would say we cool it down to 40 degrees and recursively we already solved that problem. Okay, so we can rely on that one. And so this is the idea of recursion. With that said, Let's go for a break, and then 10:15, I think we can continue. See you in the meantime.